Hello everyone. This is Saurabh Nair here. We are going to start our deep learning playlist. This is one of the introductory video that just gives a basic overview of the overall deep learning. In this lecture, our table of contents are: first of all, we are going to see the introduction, which includes the history, also the different founders or different scientists who have developed some of the concepts that we currently use, and they are very much important for us to learn. The second one is the machine learning versus deep learning. So, just overview of the how machine learning is different than deep learning. Also, we are going to see the applications. Also, a neural networks, the building blocks. Overall overview of the neural network we are going to see. We don't want to get into the deeper frameworks and deeper concepts because this is the introductory video. So in next video, I will go through a series wise the concepts that you need to understand in order to understand the deep learning best. You can see here a picture. In this picture, there are two persons. The right one is Warren McClock, and the left one is the Otter Pitch. Alter Pitch, sorry. Basically, these two are the founders of. We can say not founders. We can say they have uh, built a stepping stone for the deep learning. They are not computer scientists. The Orn is the neurophysiologist and Pitt is the cognitive psychologist. So we can see that they don't have much computer background, but due to the, as we know, the deep learning or the different machine learning algorithm also are inspired from the nature. As we know that our brain contains the neurons. So basically, they have tried to mimic the process of neurons into the machine. So, so McLock and Pitt, they have written one paper called "A Logical Calculus of the Ideas Immanent in Nervous Activity." So, why we are learning the psychological things here? So, in this paper, they have introduced one model called McLock-Pitts neuron. So, this model is very important in deep learning because at that time there was nothing, uh, there was no base for the uh, development of deep learning. So basically, this model is the base for all the deep learning architecture. So why it is important? McCulloch and Pitt's neuron, why it is important? It is neuron model was this neuron model was a game changer because it allowed the different researchers to study neural networks in a systematic and quantitative way. So before this, a steering neural network was trying to understand the weather without any instrument. So we require some basis or some instruments or some things in order to conduct some research or in order to develop some uh, architectures or some products. So at that time, the researchers don't have any basis on to work. So they have developed this model. So McLaughlin fits. So what's special in this model? So they have used the formal logic and mathematical equation to describe how neurons interact with each other. So we know that deep learning consists of different neurons. We are going to see in the future how neurons communicate with each other. It just if you don't get it, it's just a basic overview. Don't be overwhelmed or like that. So these are just basic. So formal logic and complex mathematical equations. Okay. So as you can see the formal logic. So what is formal logic? So formal logic is one of the basic branch of physiology. So that's the structure of a valid argument. So we can you can check on the internet what is the structure of valid argument or the what is the formal logic. You can see the different examples. You can get it. Also, the complex mathematical equations. As we know, deep learning heavily heavily uses the linear algebra and calculus and different mathematical different branches of mathematicals. Now, we are going to see how the McLaughlin and Pitts neuron actually looks. So, this is the picture of McLaughlin Pitts neuron. Here you can see it contains some inputs x1 to xn. This model only accepts the binary input, that is either 0 or 1. 0 representing it is like turning off, and 1 representing it's on. And also, the model outputs only two things, that is 0 or 1. So, I will just give a brief overview of how this model works. So, we provide our input from x1 to xn from this side. So, from this side, there contains some weights. So, in this McLaughlin-Pitts neuron, there is like no concept of updating weights or back propagation. We are going to see in future or back propagation is how we update the weights. So, they manually set the weights to each of the input. Say x1. Let's take one example. Let's say x1 is our first input is 1 and second input is 0. So and our set so we can set negative or positive weights. So let's say we have set weights 1 and for x2 it is also 1. So how like then we multiply our inputs to the weights. So x1 is gets multiplied with let's we call it as the w1, w2 for second weight, w1 for first weight. So x1 gets multiplied with w1, x2 gets multiplied with w2. So we know that the w1 and w2 are the ones. So we get 1 into 1, 1, 0 into 1, 0. And this at this g, we take aggregate sum, that is we sum all of the multiplication of the x1 and w1. So we know that x1 into w1 is 1 and x2 into w2 is 0. So 1 plus 0, 1. So here is the z. So g passes its value to f. So f we can call it as the activation function. Now look, we are going to see all these terms in next lectures. So don't be like what activation is, or what are the weights and how we multiply, what is g and how we aggregate. So we are going to look at that. This is just a basic overview, you can say. So this is acts like the activation function. Now we can f is like a threshold. Like if our sum gets below or gets upper than the specified the f specified number f, then we are going to output 0 or 1. So let's take an example. Let we set our f to 1. So our threshold value is 1. If our sum with inputs and weights get passed through yep, that is 1. So we output 1, otherwise it is 0. So this just acts like a threshold function. So we are going to look at what is difference between the machine learning and deep learning. So we we noted the, let's say this circle represents the artificial intelligence that. And now, the machine learning is basically a subset of artificial intelligence, which is the broader area. And you can also look at uh, or different branches the artificial intelligence includes. Also includes the machine learning and other different branches. You can look at into that. Also, now the machine learning. So machine learning also contain some subset of area which is known as deep learning. So we can see the relationship between the artificial intelligence, machine learning, and deep learning. So let's basically with the help of an example, let's look at how machine learning and deep learning is different. So now, so first of all, let me talk about the machine learning. So you imagine you have one child. You want to teach your child that how to identify a dogs. So you show them the pictures of different dogs. You can say here is the Labrador, here is Golden Retriever, and here is the Husky. So you each time you show a picture of a dog to the toddler and say this is dog, this is dog, this is dog. So after repeating it multiple times, the child starts recognizing dogs on their own. You can show them different breeds or different uh, dogs with the in within the same breed. They can also identify them as a dog. But the one key point is here, they identify it as a dog. They can't identify here the breeds of the dogs. That's pretty much how machine learning works. It's a type of artificial intelligence that trains the machine on how to learn by feeding it data and information in the form of observation and real life interaction. So this is the machine learning. So now let's move on the deep learning. So going back to the child's example, imagine now you want to teach your child that how you want to teach your child to identify the breeds of dogs. So this is a complex task compared to the machine learning, the previous tasks. That is this. So it's just task for identifying whether it is dog or not. But now we can see we have to identify the different breeds, and we can see there are different features of each breed. So you can see the husky has the ears that are straight into the air, but in Labrador or Golden Retriever, the ears are not that straight. So there are some different, like you can say this is the Golden Retriever has fluffy hairs, but uh, Labrador don't have fluffy hairs. So what's the difference? So while both machine learning and deep learning learns from data, the way they learn and the complexity of tasks they can perform is different. Machine learning algorithms need to be told how to make an accurate prediction by the programmer itself, whereas deep learning algorithms don't need any explicit programming. They can learn from processing the large amount of images or the large amount of data using neural networks. That we are going to see how neural networks train itself. And if you have done any machine learning before, you know that machine learning needs the data machine learning needs the features and it contain independent and dependent variables. So in deep learning, we don't require that because uh, deep learning algorithm neural network itself finds the features into the data. So in this image, we can see one of the feature is like the ears. We can say these three dogs had different ears. Also the color of the dogs and also the hairs of the dogs. They are the parameter that neural network learn itself. We don't explicitly need to program that features. So that's the main difference between the machine learning and deep learning. Now let's look at the applications of deep learning. So first is the computer vision. So uh, the computer vision applications involve the applications like self-driving cars, object detection, image classification, and object segmentation, image captioning. Second application of deep learning is the large language models, which includes the uh, models like ChatGPT and the BART. Also, the third area in which the deep learning application lies are speech recognition, which includes the Google uh, Assistant and Apple's Siri. So these are the key areas where deep learning has its roots. So we are going to see each area in detail in the next upcoming videos. So, so last one is the neural network, the building blocks. So here I'm going to give you a overview of how the actual neural networks looks. The McLaughlin Pitts model of the first that started this revolution, and till date they have developed to this. So these are called the neurons. Uh, they are connected with each other. So there are some terminologies that are consistent in the architecture. So the first one is the input layer, where each input goes. Uh, so the first layer is input layer. Second is the hidden layer. So this layer, which is after the input layer, is called as the hidden layer. And third layer is the output layer, where the output of the neural networks is generated. So we can see the overall architecture, and this is not a brief overview, but this is a general overview of a neural network, and we are going to look into the details of how these actually neurons communicate with each other and how they pass the information from input to output. So this is just for the video. So thank you.